Okay, so thank you everyone for coming, and especially thanks to the previous speakers because they made my work a little bit easier now. Today I'm going to present my joint work with Jose Correa and a bunch of folks from the University of Chile on school choice. And I want to start giving you some context. In Chile, we have three types of institutions. The first one are public schools, which account for 36% of the total enrollment. And these schools are administered by local governments and receive full public funding, okay? And in general, they serve underrepresented groups, people from lower income and more disadvantaged families. The second group are subsidized schools, which are administered by for-profit corporations, and these receive partially public funding, which is complemented by co-payments made by the parents. And the last group are private schools, which account for 9% of the total enrollment, and these are administered by private for-profit corporations, and they don't receive any sort of public funding. So in today's talk, what I'm going to focus on is in the first two groups of schools, and in particular in their admission processes, since we're in a matching session. And how the system worked before 2015 is that the system was fully decentralized, in the sense that parents had to assist to each school in order to submit an application. Application decisions were separate, so it could be the case that a given student was allocated to two schools. Also, the admission rules used by each school were somewhat arbitrary, in the sense that schools could choose to apply interviews, admission exams, first come, first serve, among many other ways to decide who is going to be selected. And the third component of the problem that we had before is that there was a lot of heterogeneity in the quality of schools and a huge lack of information in terms of the vacancies available, the programs of the schools, and so on. So you could see around July every year, huge queues of people waiting in order to get a seat in a given school, okay? So in order to address all these problems in 2015, a new law was passed, which is called the School Inclusion Law. And the three main components of this law are, first, to forbid for-profit corporations in the administration of schools. The second is to forbid co-payments. And the most important for the purpose of this talk is to forbid discrimination in the admission decisions. So to be a little bit more precise about what this means, it means that schools are forbidden now from selecting their students based on arbitrary decision rules. And in particular, the law defines a set of priorities and quotas that must be used by schools in order to select their students, okay? And I'll be more precise about what these quotas are in future slides. And also, and this is taken literally from the law, the system must guarantee equal treatment of equals, meaning that if I belong to a given priority or a given quota, I must have the same probability of getting assigned that others that satisfy the same quota or priority group, okay? So what I'm going to show you today are the results of a 3-year collaboration with the Ministry of Education of Chile in the development and implementation of the assignment mechanism to solve the Chilean school choice problem. And in particular, when we were designing and implementing this mechanism, we had two main features in mind. The first one is to incorporate priority groups and quotas as stated by the law, and this was a huge requirement. And the second, which was a more soft requirement, is to maximize the number of students assigned with their siblings. And I'll be more precise why this is so important in this context in the future slides. And just to give you a spoiler on what are the results, in 2018, which is the last time we run the system, it's going to run again this year, we served 275,000 students, around 60,000 schools, and 60% of them were assigned to their top choice. So these are results that are very satisfactory, and we're very happy with them. And in terms of academic contributions, in addition to adding another success case to the market design literature, we contribute from a more theoretical standpoint, providing two heuristics that allow us to maximize the number of siblings that are assigned in the same school. And in particular, we propose an updating algorithm based on the results of upper levels, and I'll be super precise about what this means next. And also, we propose the use of a tie-breaking rule at the family level to increase the chances of siblings getting assigned together. And also, we deal with overlapping types of quotas. I'm not going to focus that much in this talk today for purpose of time, and also because previous speakers have talked a lot about it. Okay? So now let me describe the mechanism. The mechanism, the basic one, is based on the student proposing deferred acceptance algorithm. I'm not going to spend time explaining that because it's already been explained twice. And the reason why we chose to implement this mechanism, and this is the most interesting one, and it was pointed out by the first speaker, is that it is easy to explain to parents. So for instance, if I have a daughter that got assigned to school X and the family complains, then it's easy to explain why that person was assigned to that school. In contrast, if we implement top trading cycles of the Boston mechanism, it is somewhat less clear to provide a compelling explanation to parents. Okay? And in addition to that, deferred acceptance has very nice properties, which we all know. First one is stability. It's a truthful mechanism in the sense that it's in the best interest of families to report their truth preferences. And this is the case in this mechanism because there is no constraint in the number of applications that students can submit. And it's also Pareto optimal for students. Okay, so it's going to be the best allocation among the stable assignments for students. And the particular features of the Chilean case are the following. So it's a multi-level setting, meaning that we solve the problem from pre-K to 12th grade. So we have to decide how we're going to process different levels. Also, it consists of 2 rounds plus an assignment by distance, meaning that the main round is where everyone participates. The complementary round is for those students who didn't get assigned in the main round. And then there is this assignment by distance, which is assigning the students that didn't get any assignment to the closest school that has remaining vacancies. And the third component, which is required by law in the Chilean context, is a tie-breaking rule, a multiple tie-breaking rule. So we'll have a single lottery number for each family, for each school they applied to. And the reason why the law was passed in this way is because they were concerned of families getting bad luck with a bad number and then being screwed up for all their applications. Okay? So now I'm going to focus on 2 particular features of the problem. The first one is priorities and quotas. So first, the set of priorities that we use in Chile are 4. First, siblings priority, then for children of employees, then for former students, and finally for everyone else. And something important here is that, as I said before, this is a multi-level problem. So what we do is to start solving the problem starting from the upper level, and then we update the priorities of the students in lower levels. So for example, if my brother was assigned in 12th grade to school X, then if I'm in a lower level, I will get higher priority due to the siblings priority. Okay? Next component are quotas. We have a low-income quota, which is roughly 50% of the total population. We have a quota for high-performing students, which is up to 85% of the number of seats in some pre-selected schools. And then we'll have a special quota for students with disabilities, which are 2 seats per school per level. Okay? And something important to highlight here is that we might have the problem of overlapping types, which has been mentioned before, in the sense that you might have a low-income student who is also high-achieving, so we have to figure out to which vacancy to assign that student. And the third main component of this problem is we have this guaranteed enrollment component, which is students who want to change their allocation, they must have the security that if they don't get assigned to anywhere, given the mechanism, they will keep their seat in their current school. Okay? So to implement all these components, what we create is like an artificial ordering for schools so that guaranteed enrollment are processed first, then students with high achieving quota or with disabilities, then siblings, low income employees, and so on. And these quotas are processed in order. So we'll start filling vacancies with guaranteed enrollment, then with high achieving, and so on. And for example, if we have a lot of people with siblings applying in that case, we might not be able to fill the quota for lower income or for things that might happen later. Okay? So as I said before, we might have the problem of overlapping priorities and quotas. And the way, and we know from the literature that if we want to count a given student in 2 quotas, a stable matching might not exist. So what we do in order to solve this issue is to assign a given student to a specific type of quota. So we create duplicates of all the programs, and then each program is going to label by a given priority or quota, and then a student uses only 1 seat in a specific type of seat. Okay? And we have a proposition that the algorithm with multiple quotas is stable under this setting and with the proper definition of stability. The second particular feature of the Chilean case is the maximization of the allocation of siblings. And the reason why this is so important is because in Chile we could not apply a priority by distance, which is the standard in many school choice settings, because Chile is a very highly segregated country and segregated by region. So if we implemented a priority by distance, what we might end up having is very poor students like being assigned to very poor schools, richer students assigned to richer schools, and we wanted to avoid that. And the second reason why maximizing the allocation of siblings is important is because transportation is not provided in Chile. So it's very important for families to get their children assigned together or assigned in schools that are close to each other in order to minimize their transportation costs. So in order to implement this, we propose two ways. The first one is this new option, which is the family application. And what I mean with this is, as a family, you can opt in or opt out this option. And what this does is, if I opt in, I declare that I prefer my children to get assigned together rather than respecting the reported preferences. Okay? And I'll be super clear about this in the next slide. And the second component that we propose in order to deal with the maximization of siblings assigned together is to use a tie-breaking rule at the family level. So we'll have a multiple tie-breaking, but each family is going to get the same lottery number. Okay? So now let me explain the preference updating algorithm. Suppose we have this tiny example where we have Alice and John, who are siblings, and then we know that everyone prefers school A over school B. And this family opted for this updating preference, so they state that they prefer attending to school B rather than to have both of the kids assigned in different schools. So here we have the high level and the low level. Think about this as 12th grade and 7th grade. And the problem can be formulated as a graph, as I'm depicting here. So this row means that Alice prefers school A over school B, and the column means that school A prefers Tim over Alice. Okay, so any question? Good. So if we apply no updating, we can run the student proposing deferred acceptance algorithm, and the allocation we're going to obtain is this. So Alice is going to be assigned to school B, and Tim is going to be assigned to school A. And in the lower level, John is going to be assigned to school A, and Monica to school B. Problem is the students got assigned in different places. So what we propose is a very simple solution, which is now we're going to consider the assignment in the higher level, which is the one I just mentioned before. And then we are going to update the preferences of John so that now he is going to prefer school B over school A. And then after this updating process, what we're going to have is, again, run deferred acceptance algorithm. And now we're going to obtain that John is assigned to school B. So by implementing this method, what we obtain is a higher chances of siblings getting assigned together. Okay? And we show theoretically that combining this updating algorithm plus tie-breaking by families increases the probability that siblings will get assigned together. Okay, so this is one of the main results of the paper. So now, let me jump to the implementation results. And how much time left I have? Okay, that's perfect. So we start with that. As I said at the beginning of this talk, this is the results of a 3-year collaboration with the Ministry of Education. We started in 2016 running this mechanism in a single region, and it was chosen in purpose to be the southest one so that if something went wrong, no one will know about it. And then the system started scaling, and in 2018, we were covering 15 regions out of 16, and as I mentioned before, 275,000 students. And this year, now the process is going to start running in July, collecting applications, and the final allocation will be returned in January of next year. And we are hoping to consider the whole country, which is 500,000 students and more than 10,000 schools. In terms of the results of the process of 2018, which was the last instance we ran, I just want to highlight with this slide that the most important priority group are those students with siblings, and this supports our idea that we want to maximize the number of siblings assigned together. And also, I want to highlight that the amount of disadvantaged students is roughly 50%. And this is something we have been debating with the Ministry of Education because the lower income quota is only 15%, and the number of students is roughly 50%. So it's a huge disbalance, but as I'm going to show you in the next slide, not in the next one, we're trying to improve the results for this group, which are the most demanding one in some sense. So here are the results in terms of the allocation in the main round, what we can see here is that most of the students, roughly 60% of them, get assigned to a top choice, and 82.5% of students get assigned to one of the submitted preferences, okay? And only 17% of them don't get assigned to any school, or they get their assignment in their guarantee enrollment school, okay? Now, what I mentioned before, I described that we want to try to help somewhat students from disadvantaged backgrounds and from lower income, and this shows that we're doing a good job in this sense. Here we observed that roughly 65% of students from lower incomes are getting their top choice, and this is slightly better than the number for high achieving and for regular students, which is roughly 50%, okay? And this, I just want to highlight the effect of the two policies we propose to maximize the number of students assigned with their siblings. If we implement only a lottery by student and no updating, which is the standard algorithm in the literature, we obtain, based on simulations, 53% of siblings assigned together. And if we implement the two propositions that we make, which is updating preferences and implementing a lottery by family, we can increase this quantity to 66%, which constitutes a 25% increment from 53%. So this is, for us, is a big achievement, and we want to keep working on proposing new heuristics to keep increasing this number, but we're very comfortable with what we're doing so far. So this is just what I mentioned before. So now let me conclude. What I presented today is the successful implementation of the admission system to solve the Chilean college school choice problem. And this system, as I said before, will be fully implemented in 2019. And in general, the mechanism that we implement is adapting the deferred acceptance algorithm, the student proposing version, in order to account for two important components. The first one is to deal with multiple types and multiple quotas and overlapping types. And the second is to maximize the allocation of siblings in the same school. And in terms of future research, what we're working on now is on trying to understand what drives preferences of families when they're applying to programs in this system. And in particular, we see that there are some biases in the sense that families with daughters apply less to more selective schools than with boys. So we're trying to understand what is driving this and try to come up on ways to incentivize families to apply to the best schools possible. And the second is the effect of forbidden selection, which is we had in the past a system that allowed selection based on arbitrary rules. Now we're switching gradually to a system that doesn't allow that. So something we're interested in is what's the impact of this change, okay? And that's what I have. Thank you. Yeah.
Yeah, so do families complain if the oldest child is not as bright as the next younger child? You see what I mean? They're sort of, you're ranking a family by how bright its first child is.
Yeah, that's
How much the school wants the first child.
That's a good point. Something to consider is that we don't allow to implement like admission exams, only in a selected set of schools. So it's not a major concern having the brightest kid applying first, being allocated first. And for those schools who do allow to select based on high achieving students, there is an issue there. And so far, this is like the first time we're implemented it, so we're not considering. But there is definitely an extension could be that the family can say, okay, I want to give more weight on this kid and then have the other one. And that's an extension that is, I think, is feasible and it will be interesting to explore.
One more question. Do you have this problem that are schools complaining, oh, we don't have enough, I don't know, we don't have a keeper on the soccer team or something, or you don't have that problem, right?
No, we don't have that problem. Yeah, and the only ways they can use to request students are based on the priorities and quotas, so they don't have a choice as in the previous, like in the first talk where they can ask for musicians or things like that.